What about real numbers? The real numbers are all the numbers on the real number line. These are the natural numbers, the whole numbers, the integers, and the rational numbers. But they also include the irrational numbers. Irrational numbers cannot be expressed as a ratio of two integers. They have an infinite amount of digits that are non-recurring. Examples of irrational numbers are pi, not this pi, or the square root of 2. So can you find a way to pair up the real numbers with natural numbers? Let's just have a look at real numbers between 0 and 1. You would have to come up with a way to write the real numbers in a systematic way. It could look something like this. But there are still lots of numbers in between, and if you keep counting like this, you will miss these out. So this is not the way. The real numbers are not easy to tame. If you look at the number line again, you can see that the integers and the rational numbers are distinct points on the line, with spaces in between, where no integers or rational numbers exist. These points are countable. However, there are an infinite amount of real numbers in between the integers and the rational numbers. If you try to count real numbers as distinct points, you will always find another number in between the 2 points you are counting. In fact, if you try to list the first real number after 0, you won't be able to list it because it has an infinite number of zeros before you get to the 1. A German mathematician Georg Cantor studied this problem in depth, and he concluded that the real number line is composed of infinitely closely spaced points. So it becomes a continuous line. He called this line the continuum. He devised a mathematical proof to show that the numbers on this line are uncountable. This proof is called Cantor's diagonal argument. Let's assume we can count the real numbers and make a list of some random real numbers like this. Can you now say you can write every combination like this? The answer is no. With Cantor's diagonal argument, you can make a unique number that is not on the list simply by changing the first digit in the first number, the second digit in the second number, the third digit in the third number, and so on. The new number will be different from number 1 in digit 1, from number 2 in digit 2, from number 3 in digit 3, and so on, right up to infinity. So in this example, this will be the new number, and this is not on the list. In fact, whatever combination you try, you will always be able to make a new number with this diagonal trick of Cantor. There will always be a unique number between any two numbers you count. The set of real numbers is uncountable infinite, and it's larger than the set of natural numbers. It has the cardinality aleph-one, and 2 to the power of aleph-null is aleph-one. The cardinality of the real numbers is the cardinality of the continuum. There are even bigger infinities with the cardinalities aleph-2, aleph-3, aleph-4, etc. In fact, there are infinitely many sizes to infinity. Had your head exploded yet? The different sizes of infinity is a very strange concept. You would think that something that is infinite would not have a size, and it seems very weird that some infinities are even more infinite than others. This is something even the best mathematicians have a lot of difficulty understanding, simply because infinity is so abstract. Many things about infinity are not even provable. For example, it can't be proven that there is a cardinality between aleph-null and aleph-one. So what is the use of knowing? Well, the understanding of the first cardinality of infinity led to the development of calculus, and the second cardinality to the development of computability of numbers. So infinity is very important in mathematics. By looking at infinity, we can appreciate the beauty and perfection of mathematics and the universe. Mathematics is never complete. As soon as you have an answer, another problem is created. We will always build on the work of others, slowly climbing the ladder to infinity. And we know we can never get there. We will always be infinitely far away from infinity. But this is okay. The journey is infinitely more important than the destination. Thank you for watching.